Okay, this is assignment 2C. Some of you are experiencing some difficulty and having some questions, so I thought I'd go over a couple things on this to help you out. Most people did pretty well in the first two problems where you had to write the equation. The equation that we were writing is in slope-intercept form on those. Because in each one of these, for the first two problems, we had a beginning charge on this one, $20 for a house call. And then we had a rate. See, the $30 per hour, that is our rate that he's charging us. And that is the slope. See, $30 per hour has to be multiplied by the number of hours to get the total cost. Which means if we have X hours, then we're going to have 30X. See, it's kind of like y equals mx. The slope is m. X is the hours. Plus b. So y, being the total cost, would be the slope or the rate, $30 per hour, times the number of hours, plus the beginning cost, or the fee, $20. And most of us did pretty well there. So for all of these x values, which are hours, we can find all the y values, which were like the cost, or the dollars, by just taking the x value, plug it in, and doing the math. So I'm just going to do one of these. So let's go to 6 hours. For 6 hours, you would have the cost would equal 30 times 6 plus 20. 30 times 6 is 180. Right? 3 times 6 is 18, so 180 plus 20. So that's 200. So if you do those, and then you plot those points, then they should come out to be some kind of a graph. Now in this one, we can probably graph this one because I'm going to go ahead and get the first one in there. For 0 hours, 30 times 0 is 0, plus 20 is 20. So this one goes all the way from 0 to 20. To 6, 200. 200 is just below 210. And then we have a straight line graph. There, all the rest of those points that we would have in the table would be on there. So the slope represents the rates that we're being charged, like $30 per hour. The hourly rate. Okay, the y-intercept is what the charge is going to be for 0 hours. So the charge for 0 hours. Let's say he drives to your house and he says, well, I just made a house call, so it's $20. But you decide not to make me or give me the job so that I'm not really working for you, but you still owe me $20 for driving out to your house. Okay, and then for 2.5 hours, you could just take that and you could either find it on the graph here, which might be a little challenging, or you could plug it into the equation. So you'd have y equals 30 times 2.5, whatever that is, plus 20. So you could do the math on that one. Okay, 2 is about the same because we have an initial charge for renting the plane plus the hourly rate. So it's very similar. I'm not going to do this one. I'm going to move on because they're so similar to each other. On problem 3, okay, so this is where it's a little bit different. We have X is the number of adult tickets. Y is the number of child tickets. Adult tickets cost $5 each. That's like a rate because it's like the cost per ticket, but that's the cost per ticket only for the adult tickets. So the total cost for the adult tickets only would be 5x. But then we also have the child tickets which don't cost $5 each, they have their own rate, and they cost $3 each, but that $3 each is only for the child tickets. So the total cost for the child tickets would be 3y. So we have the total cost for the adult tickets here, the total cost for the child tickets, and when you add those together, that should equal the total cost. And it says he can only spend $30 because that's all he's got. So equals 30. Now, when you find the graph on this one, we're going to find it using the x-intercept and the y-intercepts. Now, you have to understand what the x-intercept and y-intercepts mean on this one. The x-intercept means, well, first of all, where it crosses the x-axis. This is the x-axis. And x is the number of adult tickets. Number of adult tickets. But, see, every time a line crosses the x-axis, let's just pretend that it crosses right there. Okay, I don't know. But that point will have an x value because from the origin we go to the right sum, like however far that is, but up or down 0. Always up or down 0. On the x-axis, it's always up or down 0. So the x-intercept is the x value when y equals 0. Now, in this case, y being 0 would be 0 child tickets. So if you have 0 children go to the movies and it costs $5 for each adult, then the number of adults is going to be your x-intercept because no children. Okay? So let's find that. If y is equal to 0, then our equation 5x plus 3y equals 30 then becomes, since y is equal to 0, only 5x equals 30. Think about it. You're only taking adults. They cost $5 each. You only have $30. So divide by 5 to get x equals 6. You can take 6 adults to the movies. And I kind of want to know that number before I make my scale, because I want my scale to go out to 6. And it seems like I can count by ones, and that'll be reasonable. 1, 2, 3, 4, 5, 6. So I kind of want to have a scale there, so I know what I'm looking at. So there's one of my dots. So the x-intercept is 6. The meaning of the x-intercept means 6 adults go to the movies when 0 children go to the movies. Okay, because the x-intercept is the x value when y is equal to 0. All right, let's find the y-intercept. So the y-intercept, like anytime a line crosses the y-axis, that's the y-intercept. But the ordered pair for that is going to be from the origin across 0 and up or down something. In other words, the x is going to equal 0 at the y-intercept. So the y-intercept is the y value when x is equal to 0. So if we have an equation like this, 5x plus 3y equals 30, and if x is going to be equal 0, then the x term just drops out because it became 0, and we have 3y equals 30. And then I could divide by 3 to get y equals 10. Now what that means is that the y-intercept, remember, is a y value. That's the number of child tickets I can buy if I don't buy any adult tickets. If x equals 0, then I can take 10 children, if I have 0 adults going. Okay. So See, I kind of want to know that number before I make my scale. So in the y direction, I have to count up to 10. So I have to count all these lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then it goes up to 10. Lucky for me, then I can just put that in there like that. And put the rest of these numbers in there. Okay, so all I have to do to get the rest of my line is connect those 2 points. I don't have to do anything else. I don't have to solve for y. I don't have to know the slope. I just have to connect those 2 points with my line to get. Now, I don't have a straight line tool. Uh-oh. This is going to be a little challenging. See if I can stick something on here to make it work. Straight line tool. No. See, some of you need to use a ruler. That's not perfect, but that's the idea. Okay. Now that line represents where we can find all of our solutions to this problem. If that line was perfect, that would be awesome. It's not. But I know that one of the solutions would be right here, and that's because the line would go right through that point. And that point is 3, 5, which means I can take 3 adults and 5 children to the movies for my $30. I don't think there's any other whole number solutions on there. This one looks like it, but I don't think it is really because my line's not perfect. If my line was perfect, it would not be going through that point right there. So anyway, that's the idea with the x-intercept and the y-intercept. Let's go to a couple of the other problems. This one is very similar to the last one. Very similar. Okay. Instead of going to the movies, we're buying bird seed. Because an ornithologist is a person who studies birds. Anyway, so this is just like the $30. He spent $12, right? Going to the movies was $30. So something is going to equal 12 when we're done. Thistle seed costs $2 per pound. That's like the rate for thistle seed only. And we're going to use X for the pounds of thistle seed. Okay, so X is pounds of thistle seed. So you label your graph. Okay. So that $2 per pound for thistle seed is only for the X, so that's going to be 2X. $2 per pound times X pounds. Okay. Sunflower seed costs $1.50 a pound. That's another rate, but that rate only goes with sunflower seeds. So that's $1.50 per pound times the number of pounds, but only for sunflower seeds. So $1.50 per pound times the number of pounds of sunflower seed. Now that 2X will come out to be the total cost for the thistle seed, and the 150Y is the total cost for the sunflower seeds. So when we add them together, we should get the total cost, which is $12, because that's how much he spent. So don't solve for X or solve for Y. You don't have to. We're going to graph this using the x-intercept and the y-intercept. Okay, it's the x-intercept. All we have to do is let y equal 0. If y equals 0, the 150y drops out, and we only have this equation, 2x equals 12. Divide by 2 to get an x equals 6. The x-intercept is 6. 1, 2, 3, 4, 5, 6. Okay? The x-intercept is 6. What does it mean? It means if he only bought thistle seed, he could buy 6 pounds. No sunflower seeds. 6 pounds of thistle seed if, now I'm running out of room here, so I'm just going to say if y equals 0. If the pounds of sunflower seeds equals 0. Okay. Then find the y-intercept. The y-intercept is the y value when x is equal to 0. if x is equal to 0 in that equation, then 2x is equal to 0. The only thing we have left is 150y equals 12. Divide by 150 to get y equals 8. So the y-intercept is 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so all I have to do to find the line for everything else is connect my x-intercept to my y-intercept. Hopefully I can draw a better line this time. I'm not sure that I can, but I'm going to give it a shot. Okay. I'm using my iPad, so like anything with any kind of magnetic qualities, or if it's too thin, is not going to work for a ruler. Okay, that's not horrible, but still didn't exactly hit my y-intercept where I wanted to. But anyway, on that line, oh yeah, we should write the y-intercept as 8. What does that mean? That means if you bought 0 pounds of thistle seed, you could buy 8 pounds of sunflower seed. If x equals 0. The one other solution that we're looking for on that line is where the line would intersect whole... Well, actually, it doesn't have to be whole numbers. You can buy fractions of a pound. You can buy 3.5 pounds of sunflower seeds if you want to. It doesn't have to be whole numbers. The previous problem with the movie tickets had to be whole numbers because you can't buy like a half a movie ticket for a person. So on this one, let's see if we come down 4 and over... That's probably a solution right there. 1, 2, 3, 3, 4. And what does that mean? That means we could buy 3 whole pounds of thistle seed and 4 whole pounds of sunflower seeds and still make that with our $12. Now, if we could read these fractions, then we could buy, let's say, this is 4 and 5. So we could buy 4.5 pounds of thistle seed and 2 pounds of sunflower seed because it's on the line. Every solution to this problem is on that line. Okay, so hopefully that helps you out a little bit. Let's go forward and see if we can do a little bit more. Now, somebody had a question about this one. This is very similar to the thistle seed, sunflower seed problem because we don't have dollars this time, but we have total pounds. We have a total of 300 pounds. Okay? Now we have some 5-pound stones. Okay? So we have like, let's say the number, X is the number of 5-pound stones. Number of 5-pound stones. How did I know it was a number of 5-pound stones instead of the weight of a 5-pound stone? I already know the weight of a 5-pound stone, but to get the total weight of all the 5-pound stones, remember it's pounds per stone. Okay, that would be the 5 pounds per stone. Has to be multiplied by the number of stones. Okay, so this pounds per stone, that's my 5. Right? The number of stones is what that 5 has to be multiplied by. So this is kind of like the slope, pounds per stone. That's the rate in pounds per stone of the 5-pound stones. And it has to be multiplied by the number of stones, like in this case, X. X is the number of stones. So I don't know if that clears it up or makes it worse. The 3-pound stones, we have Y of those. So Y is the number of 3-pound stones. Okay, now I didn't put any numbers on here yet because I don't know what I need. I haven't written the equation. I haven't computed anything. So let's see if we can write the equation. So using something like this down here at the bottom right-hand corner, we're going to write 5x, which will be the total pounds for the 5-pound stones. 5 pounds per stone times the number of stones is the total pounds for the 5-pound stones. Okay? Now we need the total pounds for the 3-pound stones. The total pounds for the 3-pound stones would be 3 pounds per stone times the number of stones. That's the total pounds for the 3-pound stone. So if this is the total pounds for the 5-pound stones, and this is the total pounds for the 3-pound stones, they should add up to the total number of pounds, which is 300 pounds. Okay, so you don't have to solve for y. You don't have to solve for x. You don't have to do anything special to graph this except find the x-intercept and y-intercept. So to find the x-intercept, then you pretend that y is going to be equal 0. For example, Jacob's going to go with his little truck and buy only 5-pound stones, and he can haul 300 pounds. How many can he buy? Well, we're not going to buy any 3-pound stones, so y equals 0. So that would be 5x equals 300, and you can divide by 5 to get x equals 60. So I have to be able to count out to 60 this time. So my scale has to allow for that. So I'm going to make this 10, 20, 30, 40, 50, 60. There's my x-intercept. Okay? Now for my y-intercept, I'm going to let x equal 0. So we're pretending that he's not going to buy any 5-pound stones, only 3-pound stones. He can carry 300 pounds. So that would be 3y equals 300. Divide by 3. Because x equals 0, the x term dropped out. Y equals 100. So my y-intercept has to be 100. I have to be able to count up to 100. So I'm going to make this 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, there's my y-intercept and my x-intercept. I can draw that line by just connecting those 2 points. And it would look something like this. Oh, I got a better line that time. Nice. Okay. Just takes practice. All right, so my x-intercept, remember, was 60. What was it? I could buy 60 5-pound stones if I purchased 0 3-pound stones when y equals 0. Okay, what was my y-intercept? Oh yeah, 100. What does that mean? I could buy 100 3-pound stones when I bought 0 5-pound stones, when x equals 0. So you're getting the idea, the meaning of the x-intercept and the y-intercept. I think some of you kind of missed that from the lesson. And then our one-earth solution we need to find, now since x and y are numbers of stones, we can only really use whole numbers. Now, since I counted by tens, I'm not necessarily going to be able to find all of the whole number solutions because I counted by tens. I'll probably skip over some of them. Like this might be a whole number solution right here because that would be 5 5-pound stones and 90 3-pound stones. I could use that. You could use this one also. See, there's lots of them that you could use. You don't have to use the one that I found. You could use your own. Just find it somewhere on the graph and be able to read it and identify it. And if you use a good scale, then you can find those solutions. If you used a bad scale, for example, if you made this 100 and you counted by, 30s over here, like 30, 60, 90, then your graph would look like this, and then you wouldn't be able to tell much of anything. So please use a good scale. All right. So anyway, this point right here, it works. So 30, 50. What does that mean? I could buy 30 5-pound stones and 50 3-pound stones and still haul them in Jacob's little pickup truck without it breaking down, hopefully. All right. The ice cream sandwich problem, I just want to mention a little bit about this because a lot of you were correct on this one. If X is the number of nickels and Y is the number of dimes, then tell me why this equation will not work. Okay, reach in your pockets, pull out all the nickels and dimes, count them. Okay, so if I did that and I counted them, I had 3 dimes and 2 nickels. Now, if I have 3 dimes and 2 nickels, does that automatically make, let's see, 3 dimes and 2 nickels, is that 3 dimes and 2 nickels, is that 5 cents? No. Is it 50 cents? No. No, see, each dime and nickel has a value that's not in the problem. See, that's why this one's difficult, because those values are not in the problem. Like the movie ticket problem, the value for each ticket was in the problem. Okay, now if I said something like each nickel is worth 5 cents and each dime is worth 10 cents and you need 50 cents, then you would go, oh, okay, 5 cents for each nickel. If you want to use decimals, you can. 5 cents is like this in decimal form for each nickel times the number of nickels. Yes. And 10 cents for each dime in decimal form, it looks like this, times the number of dimes equals the total amount of money that we need. In this case, 50 cents, which in decimal form is like this. Okay. Now, just like those other problems, you don't have to solve for y. All you have to do is find the x-intercept, find the y-intercept. Okay? The x-intercept is like, what if you wanted to get this 50 cents by using all nickels? How many nickels would it take with no dimes? The y-intercept would be, what if you wanted to get this 50 cents with all dimes and no nickels? How many dimes would it take? And that's how you find the x-intercept and the y-intercept. Or mathematically, you let y equal 0 to find x. You let x equal 0 to find y. Okay? So you can finish that problem. Oh, also, by the way, you can do this one without the decimals. You can go 5 cents for each nickel times the number of nickels plus 10 cents for each dime times the number of dimes equals 50 cents. And the reason we can do that is because it's like multiplying both sides of the equation by 100 to get rid of all the decimals. And that would be okay too. All right. So going on. Now this one actually works better if you just use more logical, real-life, common sense thinking instead of math. Okay, so that's what we're going to try to do. After being at school for the first half of the semester, you decide to drive 200 miles home. So, okay, you're going to drive 200 miles home, which means you are 200 miles from home. That's important. You're 200 miles from home, and you're going to drive towards home. Because of speed limits, you can only average 50 miles per hour. Create an equation table and a graph to model your distance from home. Okay, let's not even write an equation. Okay, let's say we're just now starting the journey. We haven't started the clock yet. Boom, how far are you from home? 200 miles. Great, good start. Okay, so we're on the road. We've been on the road for 1 hour at 50 miles per hour. Going towards home. What's our distance from home? And I think you would have figured that out because 50 miles per hour for 1 hour, you're 50 miles closer to home. So that would be 150 miles. So for the next hour, 2. At 2 hours at 50 miles per hour, that's 100 miles. So you're 100 miles closer to home. You started out at 200 miles, so that would be 100. Okay? 3 hours, 3 times 50 is 150. 150 miles driven is 150 miles closer to home. So that's 200 miles from home minus 150 because you're closer. that would be 50. And if you just follow the pattern, 4, 0. Okay, so we could finish that. Now, if you think about how to write an equation, now we could plot those points. I have no problem there. But if you were going to write an equation, then make your equation make sense also. Okay, so if y is the distance from home, you're going to start, y is the distance from home, starting at 200 miles from home. Okay, start there. Right, so that would make sense, but that only works for not driving yet. Okay, now we're going to drive. We are decreasing the distance from home, so we're going to subtract. And we're going to subtract 50 miles every hour. That's miles per hour. So to figure out how many times we're going to subtract 50, well, we have to multiply that by the number of hours. If x is the number of hours, then there's our equation. Now in this one, I want to use the slope and the y-intercept, or the table. I don't want to use the x-intercept and the y-intercept, because my equation isn't in this form, you know, ax plus by equals c. This form right here is good for the x-intercept and y-intercept graphing. But this form right here is good for slope and y-intercept graphing. Okay, or making a table. Either one of those. All right. So anyway, x is the number of hours. Let's label that. We have to go out to at least 4 to get home. So we're going to make this 0. 1, 2, 3, 4. That's good. You can spread those out if you want to. And then distance from home, we have to go to at least 200. So we're going to make this, let's make this 200 way up. Oh, I don't know what to count by. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I could make this 200 and then count by 20s. See, 20, 40, 60, 80, 100. Now, you don't have to count by 10s. You could count by, let's say, 20s. You don't have to. You could count by 25s, because that way everything would end up on a nice grid mark that you're going to graph. But anyway, I'm going to do it this way just to be difficult. 0, 200. Boom. 0 hours into the journey, we're 200 miles away from home. 1 hour into the journey, we're 150 miles away from home. It's right between 140 and 160. 2 hours into the journey, we're 100 miles away from home. 3 hours into the journey, we're 50 miles away from home. So that would be right there. 4 hours into the journey, we are at home, 0 miles away from home. And there's our line. So let's draw that. Okay, fantastic. On problem 8, this goes back to very similar to the movie ticket problem. Except instead of movie tickets, George is collecting 2 different size bottles. They cost different amounts, just like the movie tickets cost different amounts. And he wants to collect $20. Just like in the movie ticket problem, we only had $30 to spend. So our equation is very similar. But on this one, I didn't tell you what to use for X and what to use for Y. So some of you are going to use X for the small bottles and Y for the large bottles. Some of you are going to use X for the large bottles and Y for the small bottles. It won't matter, but our graphs will look different. So some of you might have a graph that looks like this, and that would be okay, probably. And some of you might have a graph that looks like this, and that would be okay, probably. It depends on what you use for X and what you use for Y. So if you're comparing notes and you have one of those lines and your friend has one of the other lines, then don't just change your answer. Like, figure out if it can be okay. All right, so let's take a look. Since X comes before Y, I usually use X for like the first unknown. And the first thing we come to is 6 cents for each small bottle. So I'm going to call x, the number of small bottles. Lucky for me, my table has the small bottles first in the table, so that's x. Ha. And then y is going to be the number of large bottles. For each large bottle, it gets 10 cents. So y is the number of large bottles. Now, I should write that in there. In my y-axis, number of large bottles. See? Now my x-axis, number of small bottles. Okay, good. Now, if you get 6 cents for each small bottle, that's the rate for the small bottles. And x is the number of small bottles. So that rate, 6 cents for each bottle times the number of bottles, will be 0.06x. Okay? That will be the money for all the small bottles. See, dollars per bottle times the number of bottles ends up being total dollars. And for the large bottles, 10 cents for each large bottle, and y is the number of large bottles, so that's going to be $0.10 per bottle times the number of bottles. See, these decimals are in dollar form. 10 cents is $0.10. And then when I add those together, I should get the total amount of money, and he wants to earn $20. So there we go. Now, your table of solutions here, I'm going to graph it before making a table of solutions because I don't really want to take this equation and solve for y. You know, like I normally would when I was making a table, I would solve for y. But in this case, my equation is in this form, which is a good form for me to find the x-intercept and the y-intercept. Now, the x-intercept and the y-intercept might not always work out nice because what if it doesn't divide great? Then I'll have to do something else. But I'm going to start this way. So if I was going to find the x-intercept, then I would let y equal 0. And if y is equal to 0, then I'm going to have 0.06x equals 20. I have a bad feeling about this. So I'm going to divide by 0.06. So x equals whatever that is. Luckily, I have my calculator here. 20 divided by 0.06. Oh, that's bad news. I got 333.3 repeating. Okay. Well, it's not entirely bad news because now I have some idea how to make my scale. My scale in the x direction has to go out to at least 300 and something. And I only have 10 lines here. So I could count by 30s, or I could count by 50s. Okay, 1, 2, that I'm gonna do that. I'm gonna count by 50s. So 50, 100, 50. Oh, 150, 200, 250, 300. And so this is going to be 350 here. So even though I have to like estimate it, I know it's going to be around here somewhere. I don't know exactly where because I would have to estimate where 333 1/3 is. All right, let's go with the y-intercept. For the y-intercept, let x equal 0. If x is equal to 0, then I have 0.10y equals 20. If I divide by 0.10, that gives me y equals 200. So my y-intercept is going to be 200. I have to count up to 200. I'm going to make this 200. And I know from before I could count by 20s. So that's going to be 20, 40, 60, 80, 100. 20, 40, 60, 80, 200. Okay. Got it. All right, now, to fill out the table, good question. All right, I guess we maybe should solve for y. So let's do that. 0.06 x plus 0.10 y equals 20. So to solve for y, we're going to subtract 0.06 x from both sides. 0.10y equals negative 0.06 x. Don't forget that negative sign. Plus 20, and then divide by 0.10. Well, this isn't as horrible as I thought it was going to be. Those decimals. So now I have y equals negative 0.06 divided by 0.10 is 0.6 x. Don't forget your x. And 20 divided by 0.10 is 200. That's good because my y-intercept is 200. There's my y-intercept. Y-intercept. Now, my slope isn't really helping me that much. My slope is negative 0.6. So that doesn't help me that much. But it might help me figure out how to make my table. So let's put some numbers in here. We know that if x equals 0, y equals 200. Let's start there. What if x equals a number like 100? I know that x is going to go all the way up to 333 and a third. So I'm going to do this. I'm going to go 100, 200, 300. Let's see what happens. So if x equals 100, that's going to be y equals negative 0.6 times 100 plus 200. Negative 0.6 times 100 should be like negative 60. Negative 60 plus 200 is 140. 140. Let's see, 120, 40, 1. There it is. There is my 100, 140. Okay, let's put 200 in there. Negative 0.6 times 200 plus 200. 0.6 times 200 is negative 120. Negative 120 plus 200 would be 180. No, that can't be right. I better... Okay, negative 0.6 times 200. Yeah, that is negative 120. Plus 200, that's 80, not 180. Silly goose. All right, so 280. Got it. Hey, I got a good feeling about this. All right, let's use 300. Oh, I better put 80 over here in my table. Got it. Okay, y equals negative 0.6 times 300. That's negative 180. Plus 200 is 20. That would be right here. Oh, that's fantastic. The reason that's fantastic is because now I know that that goes right to what I thought my x-intercept was. So when I line that up and draw that line, that's my sound effect for drawing a line, just like that. So I know my points are correct because I line up with where I thought the intercept was. Oh, I forgot to write that in there, 20. Got it. Now it says find at least 5 different solutions to this problem. There's 4 of them. We have 4 of them. We need whole number values because these are bottles. The recycling center will not take half a bottle. Well, they probably would. They'd probably go on pounds of glass. Maybe. Not in Michigan, though. All right, so we need another whole number solution. So I'm going to find out where I think there is one. I think there's one right here. And the x value for that one is 150. So I'm going to say, what if I put 150 in there? And then I'm going to do the math. Y equals negative 0.6 times 150 plus 200. Do the math. Okay, I can do it. Negative 0.6 times 150 is negative 90 plus 200 is 110. It's a whole number. Yes. Okay, so any point that we find on the line, in this case, they have to be whole number values for x and y, would be a solution to this problem, just like that one. You could do it. Okay, now we're running kind of long here. Those of you who want to continue to our simple interest, here's the simple interest problem. Okay, so in this one, we have some values to put in here. I wrote the equations down, but didn't put any values in. I think we are depositing $1,000, so P is 1,000, right? And the interest rate, I can't remember what the interest rate was. Was it 5%? Yes, it was 5%. So R equals 0.05 for 5%. Okay, so all we have to do is put those in there, and then the number of years is the t, right? This t is an exponent. That's the number of years. So we have that. So we have everything we need. So to find these values that go in our table for simple interest, let's do the first one. A equals, that's 1,000 plus 1,000 times 0.05 times 0? Times 0. Oh, that's just going to be 1,000. I should have known that without writing that out. Okay. So, well, I'm going to use that for the next one. So let's erase. Oh, it's not going to let me erase because I wrote too much. All right, so for the next one, I'm going to have 1,000 plus 1,000 times 0.05 times 10. Okay, let's do a little quick math on that one. 1,000, I have my calculator. Do you have yours? Plus 1,000 times 0.05. Don't forget your decimal point. Times 10. I got 1,500. Okay, now I'm not going to write down everything for the 20 because I'm just going to change this 10 here into a 20 and do the same thing over again. Okay, 1,000 plus 1,000 times 0.05 times 20. Put 20 in there. I got 2,000. Hey, I'm going to do the same thing. I'm going to put 30 in there, so I'm going to recalculate it with 30. Put 30 in there. 1,000 plus 1,000 times 0.05 times 30. And I got 2,500. Now, did you notice it went up by 500 every time? We increased by 500, we increased by 500, we increased by 500. Okay, I just thought you ought to know that. So here's our original 1,000. So 10 years, 1,500. It's going to be right there. 20 years, 2,000. Straight line? I think so. 30 years, 2,500. 2,500 is going to be right there. Now, those are in a perfectly straight line. Let's see if I can draw this straight line again. It's going to be difficult. Okay, that's not too bad. With the tools that I have available to me, I'm going to put an arrow on the end of that. It would keep going in a straight line. Okay. Let's go with the compound interest. So we have years as 0. Now our formula is different. So, see if no, I'm not going to be able to erase that either. So for the first one, this is going to be 1,000 times 1 plus 0.05. Hey, for 1 plus 0.05 in parentheses all by itself, can I just write 1.05? That would be so much easier. 1,000 times 1.05 to the t power. Now the first power is going to be 0. So I'm going to put 0 there. Okay. Oh, got it. All right, so do the math. Oh, 0. That should be 1,000. Okay, do the math anyway. 1,000 times 1.05 to the 0 power is 1,000. Because 1.05 to the 0 power is 1, anything to 0 power is 1, and 1 times 1,000 is 1,000. Should have known. Okay, for 10 years, 1,000 times 1.05 to the power of 10. I got $1,628.89. So let's round that off to 1,630 approximately. 1630. All right. For 20 years, I'm going to change the exponent now to 20. I'm not going to rewrite it. I'm just going to go back in there, change that exponent to 20. And I got $2,653.29. So I'm just going to say $2,650. Roughly, like we're within $3.30. Okay. After 20 years, that's not too bad. So for now, we're going to put 30 in there. So let's go to 30. 30 to the 30th power, I got $4,321.94. So let's just say 4,320. Okay, now if I'm plotting just those points, they start at 1,000, just like the other one. 10 years, 1630. So this is 15. So that's a 1,000, 2,000. So this would be, let's see, 2, 4, 6, 8, 10. So this is going to be 1,200, right? 1,400, 1,600. Okay, so we're at 1630. So just above that line, right there. Does that look about right? Okay. 20 years, 2,650. So remember, these go by 200s. 22, 24, 2,650 is going to be just above that line. 2,650, right about there. Okay. And 30 years, 4,320. So 4,320 is like off the graph. Oh, man. It's okay. Remember, these lines go by 200. So this is 4,200. The next line would have been 4,400. So 4,320 is like right in between there. It's way up here. So not a straight line. That one's curved. Now that curve that we have looks just like this by hand. Oh, just hit it. It's hard to draw a nice smooth curve. Yeah, something like that. Okay, and there we go. See, compound interest, you're earning interest on the interest that you have earned. In simple interest, you're only earning interest on the principal, and the principal hasn't changed, so the amount of interest you earn every year is the same, so it goes up by the same amount every year. That's linear. Okay? Now, if I had the technology going on here, the graph might look slightly different, but the same thing is going to be happening. Okay? So, there's that, just in case any of you were curious about how that was going to go. That's fantastic. All right. So, hopefully that helped you with any questions you might have had, and we'll see you at the next Canvas chat.